Well, in this video I want to show dimensions. I've had a lot of people ask for dimensions, and so I thought I'd share that on the log splitter here. And I've used it to split that cord of wood you see back here, and this thing performed just flawlessly. Absolutely amazing. Anyway, I'll start going over the dimensions here. First of all, I have a drawing here that I'm going to show, and this angle here between the main beam and the head, that's 75 degrees, and then the angle with the spring in here at rest, let's call it, that's 115 degrees. And from the ground to the center point of that bearing, that's 43.5. And then the length of this arm is 65.5 inches. That's from the center of the bearing to right at this point. And then you could add 4 more inches to get out to the front, because this beam here, see, that's 2 by 4 inch steel. And then the overall length from the very top to the end of the blade, that's 35.5 inches. Okay, I think I covered that. And there's a reason this worked out like this. And like this is what I have here. And when the axe comes down, it's kind of calculated, I suppose, by trial and error to get the most direct hit into the wood. If you have this, I found out if you have this like 90 degrees here and the head's 90, you'll get a swiping action. In other words, right now when this comes down, see, it's actually pretty straight. From that, if you drew a center line straight down, there might be at the most an inch. And it's really a direct hit right on through there. Whereas if you had this at 90 degrees here and this arm was straight out, what you end up with is, when it's coming down, it's a swiping action like this. I don't know how else to explain it. It's what you don't really want, but it'll swipe like this as opposed to just more of a straight angle. So that's really a key to the design. And also, this was important, I think, to have this bar this way, because when you're standing here pouncing through this wood, if this bar came out, there's times when you bend over to get your wood or something, and this can still be bouncing on its own. Well, you have to watch that, because if you have something coming out here, you're gonna hit your head. So watch that. This worked absolutely flawless. This was magnificent to hold the wood. And I've added this board here because there were times when the wood wanted to just ricochet out and hit you where you didn't want to be hit. Anyway, in the spring, this is just out of actually a Ford full-size car. It was a rear spring. I don't know the name of it, unfortunately, but I'll get my tape measure. But the spring it's about 6 1/4, and then right now it's obviously compressed, but it's about 1 foot right now. So uncompressed, it might have been, I don't know, 14 inches, let's say. And this mechanism here really works good to keep that spring. Let me bounce it there, you can watch. That keeps that spring nice and flat. See, it doesn't have to go through all these gyrations otherwise. But all this has just worked perfect. And I've added some T-posts here to hold it down, because when you're pouncing through there's an enormous amount of forces applied to that wood, and things tend to want to move around. And on my rack down here, or on the stand, I added this piece with that pin, and that locates this table so it doesn't move around. Because you're going to want this not to move around, or whatever you have. I don't know what, but you don't want this table moving around. So works just fantastic, I tell you. Just really happy with it. And this was just really something else. And what these are, this is a T-post. Just a regular old T-post, like those T-posts I've driven in. And you want, what you want here, these knobs, these knobby parts, that adds a lot of grip to hold the wood. You really want that. And gee, I don't know what else to say other than, oh, one thing I'm going to add is when you cut through and you let go loose, where you're going to stick your hand in here to grab wood, and this could still be bouncing, and you could theoretically hit your hand there on top of that wood. So I'm going to add a lever here with the cable, like a cable or a steel rod come down. I'm going to put a brake caliper here with a solid piece of metal, just like a disc brake in a car, except just add, all you need is just a piece of steel here, a flat plate, then I'll mount a caliper right here. And you don't have to have all this hydraulic, just you can design a crank that'll put pressure on that pad when you let loose, and then just have another lever to go back and forth on the caliper pad. You know, that's just something a guy can figure out. That's all part of fun of figuring out stuff. I'm not going to give you all the answers, but I'd recommend that. But that hopefully this will be enough to get you through if anybody wants to build one of these. And probably one other dimension I should show from the center, that bearing to the center here is 9 inches. I made provisions to test different positions for different spring tensions, and I haven't had any need to move it. And even this part, I have not moved that once. So all this probably wasn't necessary. You know, you could probably build this permanent and then just figure out some way to get this arm up to get the spring in there initially. Anyway, hopefully that's going to help out. And this here was nothing more than, in my shop I have a crane, and this was just to lift this head up, to set it down on here, and to, you know, just to work with it. All right, have a good day.